Welcome to this recording on quadratic inequalities in one variable for Unit 9, Chapter 9 of Mathematics 2200. We'll be developing strategies to solve a quadratic inequality in one variable. A quadratic inequality in one variable is like a quadratic equation, except it has a greater than or other inequality symbol instead of the normal equal sign. Now, if a value satisfies an inequality, a quadratic inequality in one variable, it must make it true. So when I put 3 into this one, I get a false statement because negative 2 is not greater than 0 for sure. Whereas in this one, when I put in the x equals 4, I get a true statement. 0 is less than or equal to 0, but it's only true because I happen to have an equal sign in this case. Let's have a look at these two inequalities. They're exactly the same except one has the equal sign, the other one does not. Before we do anything with those, though, let's take a look at the corresponding equation, 2x plus 1 times x minus 1 equals 0. We find the roots. Now I want you to keep your eye on those two values because those values are in this table. Let's see what happens. I've also marked both of those values on these two number lines. I've put the negative decimal 5 in each bracket. And now let's see what happens. 2 times negative decimal 5 is negative 1 plus 1 is 0 times negative 1 decimal 5 greater than or equal to 0. Yes, that's certainly true. In the meantime, though, in the other one, it's going to make it false because there's no equal sign. So this first number line, I'm going to keep track of what I'm doing with the 2x plus 1 times x minus 1 greater than or equal to inequality. And the second number line, I'm going to keep track of what's happening with the greater than version. For the negative 1/2 or negative decimal 5, I got a true statement for this one. So I'm going to leave that as a solid dot. But I got a false statement here. I'm going to circle that dot. When I put the 1 in, I wind up with 1 minus 1 in this bracket, which is 0. 0 times the first bracket is going to give me 0, and 0 is certainly greater than or equal to 0. That's true, whereas in the second case, I'm going to get a false statement. So I've got to circle the 1 on this number line because I got a false statement, keep it solid on this number line because I got a true statement. Now working with some of these other values, negative 2, I'll mark that, that's before this negative 1 here. So that's going to be a test value we're going to use for both number lines. When I put in negative 2, I wind up with negative 3 times negative 3. It's a negative times a negative, which is a positive, and that's obviously greater than or equal to 0. And of course, it's obviously greater than or equal to 0 there, so that's true. Not greater than or equal to, greater than, I'm sorry. So on my number line, I will record I got a true statement when I substituted that value in. Well, it looks like I wind up with 1 times negative 1 when I put 0 in. That's going to be false. It's not greater than or equal to 0. And of course, it's also false in the other one. So keeping track of that on my number line, my 0 is between the negative 1/2 and the 1 in both cases. And meanwhile, when I put in the 3, I get true statements again. So let's record those on the number line. So in my first case, my true intervals are x less than negative 1/2 and x greater than 1. Make that less than or equal to negative 1/2 and x greater than or equal to 1. Whereas in the second case, I couldn't include the negative 1/2, so that interval is x less than negative 1/2. And this one is x greater than 1. And I shade my number line to indicate those intervals, like this. Little arrowheads at the end in this case because those intervals keep on going. Let's put all that together and solve this inequality. Write the corresponding equation and find its roots. I'll do that up here. corresponding equation is x squared minus x minus 12 equals 0. We factor, so that gives us roots at x equals 4 and negative 3. I mark those roots on the number line. Because there's no equal sign, I know it won't satisfy my inequalities, so I can cross them off and just put circles around those points. Now, I use test values in each interval to determine which intervals satisfy the inequality. So the first interval is x less than negative 3. So x less than negative 3. Let's take a test value before negative 3. Let's say negative 4. I get 8 less than 0 when I substitute negative 4, and so I get a false statement there. So my test value is negative 4, which returned a false statement. Now, from negative 3 to 4, that interval, I'll use 0. Nice and easy. That gives me the statement negative 12 is less than 0. That's obviously true. So I'll mark that up there on the number line as well. The last interval I want to look at is x greater than 4, so I'll choose a test value of 5 and see what happens. I get 8 less than 0. That's obviously false. I'll mark that up there. And I shade the only interval that is true. That would be this one right here. So my solution is that I can choose any value of x between negative 3 and 4 to satisfy the inequality. You can also use a notation you learned about in Math 1201, interval notation. X belongs to the interval negative 3 to 4. The round brackets indicate negative 3 and 4 are not included in the solution. Key ideas: the solution to a quadratic inequality in one variable is a set of values. Here are the steps for solving a quadratic inequality. And if you have an equal sign involved, make sure you include the roots in the solution set.